Okay, so this is question 1b in exercise 1E from further maths year 2 textbook, complex numbers. So you're going to prove that the left-hand side sum can be simplified to I cot pi over 2n. So on the left-hand side here we have got a geometric progression. There is n plus 1 terms because we start from 1 and we multiply all the way up to z to the power of n. So the value of a, which is the first term, is 1. The value of common ratio, which is r, is z, and there is n plus 1 terms. So we're going to replace it, the left-hand side, with the sum of n plus 1 terms. So remember geometric progression, the formula is a 1 minus r to the power of n over 1 minus r. So over here the left hand side can be replaced with a, which is 1, then you've got 1 minus z to the power of n plus 1 because we've got n plus 1 terms over 1 minus z. So let's replace our z with pi over ni. So here when you raise this pi I over n to the power of n plus 1, and then 1 minus e to the power of pi I over n. So in the denominator we can factorize half of that power, e to the half of that power out. So we are trying to make the denominator real. So that means you need to divide that by 2. And you'll be left with e to the power of minus pi I over 2n minus e to the power of pi I over 2n. Now this here, that can be replaced. Remember the formula is z to the power of n minus z to the power of minus n is equal to 2i sine n theta. If it's a plus, it will be 2 cos n theta. So in the numerator, let's do a little bit of work on that power. So that power here is going to be e, so you will have e to the power of n plus 1 over n, if you multiply it by that, pi I. Now if you look very carefully, this can be split into 1 plus 1 over n, so you've got e to the power of 1 plus 1 over n pi I. Now again, if you carry on multiplying it out, you have e to the power of pi I multiplied by e to the power of pi over ni, and this here is equal to minus 1. Let me just separate from this result. There you go. So you will have altogether minus 1 times e to the power of pi over ni, which will replace the top right side of the numerator. So altogether in the numerator we'll have 1 minus, and then this minus 1 times e to the power of pi over ni. Now this here will go into a plus. We can bring this to the top and multiply it by e to the power of minus pi I over 2n, and in the denominator we are going to have 2i sine n theta. So let's multiply this out. Let's do that. This will become e to the power of minus pi I over 2n plus e. Now if you add these two together, that means you've got pi over n minus pi over 2n, multiply this by 2, obviously there's I as well, that will become 2 pi minus pi, so 1 pi over 2n. So you will have pi over 2ni, and that is what's in the numerator. That by itself is using the other result, z to the power of n plus z to the power of minus n, can be replaced with 2 cos n theta. So it's 2 cos pi over 2 n. Yes, I'm just thinking about the denominator. I've made a mistake, sorry. That should be, I've just put n theta, copying it from this. Let me just copy that. That should be pi over 2n. Apologies, I'm not redoing it again. So this here, that's my numerator. And I've used this result for the numerator. And this here, because the argument was... in fact here, I've made 2 mistakes. Apologies again. Minus here, let me just very carefully, in order to use this I need to have the positive power written first. So I have minus e to the power of pi I over 2n minus e to the power minus pi I over 2n, which gives me minus 2i sine pi over 2n. So let me put that minus there. Good. So now over here, let's replace it with 2 cos pi over 2n. And in the denominator, I've got minus 2i sine pi over 2n. We are aiming to have cot pi over 2n, and this here is my cot pi over 2n. So just showing that 2 over minus 2i is going to be equal to I. So 2 over minus 2i, if I times that by I and this by I will have 2i over minus 2 times minus 1. So it's 2i over 2, which is I. So the 2's cancel, and you will be left with cot pi over 2n, but this simplifies to I. So I hope this